Assalamualaikum and a very good evening to Dr. Emilia and my fellow friends. So today my group will presenting the third case study, which the title is Asahi Kasei's polycarbonate synthesis. Before we begin, let me introduce myself and my group members first. So my name is Anis Marliana binti Muhammad Hir and my group members are Nurul Anis Auni binti Hussein and Siti Nohanani binti Sidi. So let's start the presentation now. Basically, this is the list of contents for our presentation today. You guys can read here by yourself. And then I will explain roughly about the introduction for our topic first. So firstly, Asahi Kasei was the world's first corporation that has succeeded in development of a new green process for producing an aromatic polycarbonate (PC) using carbon dioxide as a starting material. And aromatic polycarbonate produced basically are based on bisphenol A, which is also known as PC, but without using phosgene and methylene chloride. Then next, before the Asahi Kasei synthesis was revealed, more than about 93% of the PC has been produced by the phosgene process, which use phosgene made from carbon monoxides and chlorine as a monomer. And then, however, the phosgenes was processed naturally involved a huge number of environmental and economic shortcomings in addition to the high toxicity of phosgene itself and the high carcinogenic probability of methylene chloride itself. And then this new process created high yields and high quality PCs, also high purity monoethylene glycol (MEG), starting from ethylene oxides (EO), carbon dioxides and bisphenol A. This actually proved that the new technology from Asahi Kasei not only overcomes the environmental and economic problems existing in the phosgene process, but also achieve resources conservation and energy conservation. Besides that, this new process contributes to the Earth environment by the 17% reduction of carbon dioxide emission, which actually equals to 173 tons per 1,000 tons of product polycarbonate (PC). And lastly, the new process was carried out a commercial application about 50,000 ton per year involving the PC plant of Chime Asahi Corporation, which a joint venture between Asahi Kasei Corporation and Chime Corporations. So that's it, a little bit about the introduction for this topic. And then we move on to the aim of process modifications. So firstly, the aim is to verify economy and energy efficiency of the new process, which specifically to achieve profit oriented of the new highly efficiency using carbon dioxides, and not only to reduce the energy consumption through improve the yields, but also reduce carbon dioxide emissions. Next is the aim is to establish technology for stable productions by optimizing operating conditions and equipment, which this means that the stability and operability as an industrial process has been confirmed through over 1,000 hours of continuous operations. And lastly, to establish a production process using carbon dioxides as a safe feedstock instead of highly toxic phosgene, which the carbonyl group of polycarbonate is obtained from carbon dioxides rather than from phosgene as with the conventional process. So I think that's all from me. I will pass this presentation to my friend Hanani now. Thank you.
Okay, So now I will proceed with the next, which is the comparison between the conventional method and the new method, which is Asahi Kasei methods. Okay, so in the conventional methods, the polycarbonate synthesis was called as phosgene process, where the carbon monoxide was used as the starting material. So this is the reaction scheme of conventional methods, which is the phosgene process to form the polycarbonate. So first of all, the carbon will react with oxygen to form carbon monoxide, while the sodium chloride and water will undergo electrolysis to form chlorine and sodium hydroxide. So the carbon monoxide will react with chlorine to form phosgene with a formula of COCl2. The phosgene will then react with bisphenol A and also sodium hydroxide with the presence of catalyst. The product then will undergo interfacial polymerization in the presence of H2O and dichloromethane as the solvent. The product then will rinse with water and it will produce byproduct which is water, sodium chloride, catalyst, and dichloromethane. This is the wastewater that has to be treated. After the product has been rinsed, it will undergo desolvation and drying. At this step, it will release dichloromethane gas. The product then will undergo pelletizing as the product because the product is formed in the powder form, so it has to undergo pelletizing to form a pellet polycarbonate. In the Asahi Kasei methods, this is new process method which known as Asahi Kasei method, which was revealed to replace the previous method with more improvement achieved in order to achieve a green chemistry concept. So in the Asahi Kasei method, it does not use carbon monoxide as the starting material. However, it used carbon dioxide as the starting material. So the reaction scheme will goes like this. So first of all, the carbon dioxide will react with the ethylene oxide to produce ethylene carbonate. This is ethylene carbonate. So in the first reaction, the carbon dioxide will react with ethylene oxide to form ethylene carbonate. And then the ethylene carbonate will react with methanol. Ethylene carbonate will react with methanol to produce dimethyl carbonate. This is the intermediate and this is the product. So at the second reaction, the ethylene carbonate will react with methanol to form dimethyl carbonate and ethylene glycol. And this ethylene glycol. At the third, in the third reaction, dimethyl chloride will react with phenol to produce diphenyl carbonate. This to form diphenyl carbonate and also methanol. In the fourth reaction, the diphenyl carbonate will react with bisphenol A to produce the polycarbonate and the phenol. So this reaction is recycle. It means reversible, as all the raw material is completely used and recycled to the preceding step. So here is the main characteristics features of Asahi Kasei's new process. First of all is non-environmental drawbacks, which is in the new process method. It has non-environmental drawbacks as the process free from phosgene, methylene chloride, and the process is from water-free and chloride-free. Second is carbon dioxide used as the starting material. To generate the production of ethylene oxide. Third is high yields and high selectivity achieved in both monomer production step and the polymer production step. Fourth is all intermediate products is completely used, such as ethylene carbonate, dimethyl carbonate, methanol, diphenyl carbonate, and phenol are completely used or recycled as raw materials of the next reaction step or the preceding reaction step. So number 5 is no waste processed water to be treated, as there is no presence of water in the process. So there's no water to no waste processed water to be treated before discharging. And next is monoethylene glycol can be selectively produced in high yields by the energy saving process because no usage of processed water in the previous step. Next is purification and separation steps are necessary. So in the Asahi Kasei's new process, the purification and the separation steps is not necessary because the molten polycarbonate they obtained from the polymerization step can be directly pelletized to conserve energy compared from the phosgene process. The polycarbonate that produced was in the powder form, so it must be made to pellet by heating and melting process. So the comparison between the two methods, so in the conventional method, the synthesis of carbonate groups of polycarbonate were derived from carbon monoxide as the starting materials. So before the new process was revealed, more than 90% of polycarbonate has been produced by using phosgene process, and however the polycarbonate contains chlorine impurities. So the few drawbacks was present from the conventional method, such as it needs to use highly toxic and corrosive phosgene that made from carbon monoxide and chlorine as the monomer. It also needs to use very large amount of water and dichlorine methane. It also needs to clean large amount of wastewater as we reach the product. Therefore, so in the Asahi Kasei's polycarbonate synthesis was revealed to overcome the drawbacks from the conventional process and to achieve resources and energy conservation. So from the Asahi Kasei's method, it enables high yield production of the two products. It also free from chlorine and high quality monoethylene glycol starting from ethylene oxide by produce carbon dioxide and bisphenol A. The methods also also contribute to the Earth environment by the reduction of carbon dioxide emission due to all carbon dioxide was utilized as the component consisting main chains of the product. So the key green chemistry concepts from the Asahi Kasei polycarbonate synthesis, first of all is the use of catalyst. So the reaction will proceed smoothly using catalysts such as alkali or alkaline earth metal halides, amines, guanidine to give the ethylene to give it to give ethylene carbonate continuously in high yield. It also use of safer solvent, which is carbon dioxide as a starting material so that it will not produce highly toxic and corrosive phosgene. Third is less waste product produced. As the all intermediate products was completely used or recycled as raw material for the next reaction step, so it will produce less waste product. So when we have less waste product, so it will save the cost running. And then the fourth is environmental friendly. So the Asahi Kasei's new process reduce the emission of carbon dioxide gas, which is it contribute to the Earth environment. So next I pass to the next presenter.
Okay, so I'll continue the presentation with the benefits of Asahi Kasei's new process. Okay, so the first one is the new process has no environmental drawbacks that are present in the previous process which used phosgene. So the new process is phosgene free, dichloromethyl free, chlorine free, and also does it use any corrosive solvents such as hydrochloric acid. And then the second one is the new process is material saving due to high yields and also selectivity, which is more than 99%, and also it complete reuse of all the intermediates such as ethylene carbonate, dimethyl carbonate, methanol, diphenyl carbonate, and also phenol that are used for the next or preceding reaction. Okay, next, the cost of the overall process is also low as the process does not use any submaterial or also solvent. Next, it produces high yields and also high selectivity that are achieved in both the monomer production step and also the polymer production steps. And the new process also produce no waste and no wastewater necessary for disposal treatment before discharge to the body or water body. The next one is the whole process is safe as it use of low toxic reactants, phosgene free, and also dichloromethane free. And the last one, the new process use a small amount of catalysts, and the catalysts are recycled in the monomer production steps. Okay, so in conclusion, Asahi Kasei's new phosgene process, new non-phosgene process, practicing green and sustainable chemistry that can contribute to society in several aspects. For example, utilization of carbon dioxide emitted into air, safer plant, and also environmentally benign process. And the new process has also economic advantages to the conventional phosgene processes, both in the plant construction cost and also in the feedstock cost. So here are the references that we use for this case study. And that's all from us. Thank you for listening. Don't forget to wear your mask and also follow the SOP. Have a nice day.